Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of the solid into which the front view face, the top view face and the left hand side view face of the solid, they have been combined into a single 3D isometric projection. And using the information available with us through this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections of the solid. So in order to determine the orthographic projections of the solid, we are required to obtain the dimensions of the front view face, the top view face and the left hand side view face corresponding to the solid. Now when we are going to look at the solid from the front view orientation, we observe that the width of the solid happens to be equal to 180 millimeter, while the height of the solid has not been provided to us. So we can check there are two segments corresponding to the solid. One segment is lying towards the left hand side of the solid, while the other segment is lying onto the right hand side of the solid. So we can check the height of the solid corresponding to the left hand side portion of the solid, it happens to be equal to 70 millimeter, whereas corresponding to the right hand side segment of the solid, the height of the solid happens to be 30 millimeter plus 20 millimeter plus 35 millimeter. So the total height of the right hand side segment of the solid happens to be equal to 85 millimeter. So we observe that the two segments of the solid, that is one onto the left hand side, another one onto the right hand side, they are not having equal height over here. So the front view face of the solid will be having the dimensions 180 millimeter width of the solid and 85 millimeter height of the solid. Whereas when we are going to look at the solid from the top view orientation, so we observe that the width of the solid, it will be equal to 180 millimeter, while the depth of the solid happens to be equal to 70 millimeter over here. So the top view face will be having the dimensions 180 millimeter by 70 millimeter. Whereas when we are going to look at the solid from the left hand side view orientation, so we observe that the depth of the solid happens to be equal to 70 millimeter, while the height of the solid happens to be equal to 85 millimeter. So the side view face of the solid will be measuring 70 millimeter by 85 millimeter. So with this information, we are required to obtain the orthographic projections corresponding to this engineering object. Now, in order to obtain the orthographic projections, we have drawn the XY reference line, the X1, Y1 reference line and a transfer line originating from intersection of the XY and X1, Y1 reference lines inclined at an angle of 45 degree with respect to the XY reference line. And this transfer line we are going to require in order to transfer the distances from the top view projections alongside the depth of the solid into the left hand side view projections over here. So now since we are going to obtain the orthographic projections of the solid into the first angle projection method, so the front view projections of the solid, they will be obtained above the XY reference line. Similarly, the top view projections of the solid will be obtained below the XY reference line, while the left hand side view projections of the solid will be obtained on right hand side of the front view projections above the XY reference line. So now we know that the width of the solid happens to be 180 millimeter. So we have marked this width equal to 180 millimeter into the front view projections by drawing two vertical projection lines which are separated by the distance is equal to width of solid equal to 180 millimeter, and these two vertical projector lines we have extended appropriately into the top view projections as well, because into the top view projections also we are going to require the width of the solid equal to 180 millimeter. Now we know that the height of the solid happens to be equal to 85 millimeter. So now we have marked this height of the solid equal to 85 millimeter by drawing a horizontal projection line parallel to the XY reference line at a distance of 85 millimeter from the XY reference line, and this horizontal projector line we have appropriately extended into the left hand side view projections over here, because into the left hand side view projections as well we are going to require height of the solid equal to 85 millimeter. Next we have got the depth of the solid into the top view projection. So now we know that the dimensions of the top view face, it happens to be 180 millimeter width of the solid and 70 millimeter depth of the solid. So we have marked this depth of the solid into the top view projections by drawing two horizontal projector lines separated by the distance is equal to depth of the solid equal to 70 millimeter, and these two horizontal projector lines we have appropriately transferred into the left hand side view projection view over here by using this transfer line. So now we can check that into the left hand side view projections we have been able to obtain depth of solid is equal to 70 millimeter along the XY reference line, and height of the solid it is equal to 85 millimeter over here. So this way we have been able to obtain the front view face, top view face and left hand side view face of the solid into the orthographic projections over here. So now we can see that we can divide the solid into three elements. Element number 1 happens to be a horizontal wave which is lying onto the ground, and this horizontal wave it is carrying a T slot at the base of this horizontal web over here, so that this component can be secured safely onto the top of the bed of a machine over here. So now we can see that there is element number 2. This element number 2, it is a rectangular block which has been sectioned by a circular arc at the top surface having radius is equal to 22 millimeter, and this rectangular block it happens to be perpendicular to the front face of the solid over here. Now we have got another element which we are going to label as element number 3. So this element number 3 happens to be a vertical wave which is carrying a circular hole at the center, and this vertical wave happens to lie towards the right hand side portion of the solid, and this vertical wave happens to be once again perpendicular to the front face of the solid. Now as we are going to look at the solid from the front, we observe that this thickness of the vertical web, which is element number 3, it has not been provided to us directly, but we know that total width of the solid is equal to 180 millimeter. So let us evaluate distance of this point from the left hand side face of the solid. So this distance is 20 millimeter. This distance happens to be 22 millimeter, that is equal to the radius of the arc. This distance has been provided to us as 18 millimeter. So the total distance of this vertical surface from the left hand side face of the solid, this is equal to 60 millimeter. We have been provided with the information corresponding to this rectangular cross section, that is top surface of the horizontal web. We have been provided with this distance is equal to 90 millimeter. So 60 plus 90. This distance becomes 150 millimeter up to this vertical surface over here. So the width of this vertical web happens to be 30 millimeter. So now let us plot all of these distances alongside the width into the front view projections over here. So from the right hand side face, there is a vertical web perpendicular to the front face of the solid. The width of this vertical web happens to be 30 millimeter. So we have marked this width into the front view projections, and we have drawn a vertical projector line into the front view projections, and we have extended this projector line into the top view projections as well. Next, we have got this rectangular vertical surface corresponding to element number 2. Now we know that the distance between this vertical surface and this vertical surface, it happens to be equal to 90 millimeter. So we have marked a distance of 90 millimeter from the right hand side face of this vertical web over here. Now we can draw a vertical projector line into the front view projections, and this vertical projector line we have extended into the top view projections as well. Now we know that corresponding to element number 2, we have got two segments into element number 2. The first segment is the horizontal rectangular surface at the top over here, and the width of this rectangular top surface of the element number 2, it happens to be 18 millimeter. So now we are going to mark a distance of 18 millimeter from this vertical surface over here. So now we will be able to obtain the location of the starting point of this circular arc, and we have drawn a vertical projector line into the front view projections over here, and we have extended this vertical projection line into the top view projections as well. Whereas corresponding to the left face of this element number 2, which is a rectangular block carrying a circular cross section at the top surface over here. So now we know that this distance corresponding to the radius of the arc happens to be equal to 22 millimeter. So now this surface we can obtain while we are going to move towards left side by a distance of 22 millimeter over here. So now we have marked a distance of 22 millimeter, and we have drawn a vertical center projection line into the front view projections, and we have extended this projection line into the top view projections as well. So now automatically this remaining distance becomes 20 millimeter over here. So this way different segments along the width of the solid we have been able to obtain into the front view projection. Now we know that the height of this horizontal web which is lying onto the ground, it is equal to 30 millimeter. So now we have marked a distance of 30 millimeter from the ground, and we have drawn a horizontal projector line at a distance of 30 millimeter from the base of the solid into the front view projections, and we have extended this horizontal projection line into the left hand side view projections as well. Now we also know that onto the right hand side element number 3, which is a vertical web perpendicular to the front face of the solid, the center point of this circular slot and the center point corresponding to this semicircular top portion of this vertical web, it is going to lie 20 millimeter above the top surface of the horizontal web over here. So from the top surface of the horizontal web, we have marked a distance of 20 millimeter above the top surface of this horizontal element or the horizontal web over here. So this horizontal center line projection we have marked into the front view projections, and this center projection line has been extended into the left hand side view projections as well. Now we also know that corresponding to this particular center line, this is a center line that we have been able to obtain over here. So there is a circular hole which will be available onto this vertical web which is located towards the right side portion of the solid. So the radius of the circular hole is equal to 10 millimeter and the diameter will be equal to 20 millimeter. So from the center line which we have obtained over here, we are going to take an offset of 10 millimeter above the center line and an offset of 10 millimeter below the center line, so that this diameter of the circular slot into the vertical web can be located onto the right hand side portion of the solid. So we have drawn two black horizontal projector lines over here which are going to depict the diameter corresponding to the circular hole into the right hand side vertical web over here, and these two projector lines we have extended them into the left hand side view projections as well. Further, we know that onto this base horizontal web which is having thickness is equal to 30 millimeter, so we have been provided with a T-shaped slot over here such that we should be able to secure this object onto the top of the machine surface over here. So now we have been provided with the information that this height of the horizontal element, it has been divided into three portions over here, and each segment it is having height is equal to 10 millimeter. So we can check, this is the top surface of the horizontal element, it is having height is equal to 10 millimeter. This is this T portion of the slot, again it is having height is equal to 10 millimeter, and this is the base portion corresponding to the T slot into the element number 1, it is also having height is equal to 10 millimeter. So now we have marked all of these three segments corresponding to the T slot which is available with us onto the base element number 1 over here. So now corresponding to these three elements over here, we have marked two horizontal projector lines in such a way that this height of the horizontal element of the solid, it can be divided into three equal parts over here, and each segment it is having height is equal to 10 millimeter. And these two horizontal projector lines, they have been appropriately extended into the left hand side view projections as well. So now we know that corresponding to this rectangular block which is having a height of 40 millimeter above the top surface of this horizontal element number 1, we have got this distance equal to 40 millimeter over here, and this distance we have marked into the front view projection such that the top surface of this rectangular block, it can be located appropriately into the front view projections over here. Now why we have marked this as a center line? Because from this point we are going to draw a circular arc over here having radius is equal to 22 millimeter. So now this point is going to lie 40 millimeter above the top surface of the horizontal web or the element number 1 over here. So once we draw this center line at a height of 40 plus 30, 70 millimeter above the ground, so we are able to obtain the top surface of this rectangular block which is resting on top of this horizontal web towards the left hand side portion of the solid over here, and we have extended this center projection line into the left hand side view projections as well. And now since we have located the center point corresponding to this arc having radius is equal to 22 millimeter at this position, now we can see we have marked this radius of the arc equal to 22 millimeter. Now we have been able to obtain the front view projections corresponding to different elements of this object. So let us start joining different segments of the edges which are visible to the observer when the observer is going to look at the solid from the front view orientation. Now we can check when the observer is going to look at the solid from the front view, so this portion of the solid, it will be visible to the observer. So that is why we have marked this portion of the object using the object line projections over here. And now we observe, because this is a semicircular portion, it is being represented into the front view projections as an apparent shape, whereas corresponding to this portion, that is below this circular portion, so this portion will be represented as true shape into the front view projections over here. So below this center line, so this is our center line over here. So below this center line, we are able to observe the true shape of this surface into the front view projections over here. Similarly, we can join this portion, circular portion, and then this is a stepped portion over here. So now corresponding to this portion, we are able to observe true shape projection of this surface into the front view projection. Now another thing, we know that this horizontal surface corresponding to the T-slot, this horizontal surface corresponding to the top of the T-slot. So these two horizontal surfaces, they will not be visible to the observer from the front view orientation. So we are going to obtain hidden line projections corresponding to this surface and corresponding to this surface of the solid, which is available with us corresponding to the presence of the T-slot onto the base of this engineering object over here. Another thing, we know that this circular hole, it is also not visible to the observer from the front view orientation. So we will be able to obtain the dotted line projections corresponding to this circular hole which is available into this vertical web which happens to lie perpendicular to the front face of the solid over here. So this way we have been able to obtain the front view projections corresponding to the solid. Let us now proceed to evaluate top view projections corresponding to the solid. So as we are going to look at the solid from the top, we observe that this T slot, it has been provided centrally onto the base of this object. Now we observe that the depth of the solid happens to be 70 millimeter. So since this T slot is located centrally with respect to the depth of the solid, so we are going to measure a distance of 35 millimeter from the rear face of the solid, and a horizontal center line projection we have been able to obtain into the top view projections, and this projection line has been transferred appropriately into the left hand side view projections using this transfer line over here. Now we know that the distance of the base of this T slot, it happens to be equal to 20 millimeter. So we have marked this distance of 20 millimeter corresponding to the base of the T slot, and we must check it out over here. This distance of 20 millimeter and this distance of 20 millimeter. So this distance of 20 millimeter corresponding to the T slot, and this distance of 20 millimeter corresponding to the circular hole, they are going to overlap with each other into the top view projections over here. So corresponding to the circular hole over here and corresponding to the base of the T slot, we have been able to obtain two horizontal black projector lines into the top view projection, such that each one of these two black projector lines, they will be drawn at an offset distance of 10 millimeter from the center line. And these two projector lines, we have also transferred them into the left hand side view projection view using this transfer line over here. Now next, we have been provided with the information that the remaining distance over here, it will be 25 millimeter, and the remaining distance over here corresponding to the base of the T slot, it will be equal to 25 millimeter. Now when we look at the solid from the top, so we observe that this portion regarding the boundary of the solid, it will be visible to the observer from the top. So we have drawn a rectangular projection into the top view projections corresponding to the boundary of the solid. Now we also know that the width of this vertical web, which happens to lie perpendicular to the front face of the solid towards the right hand side portion of the solid over here, it happens to be 30 millimeter. So the top view projections corresponding to this vertical web, they will be obtained as apparent shape rectangular projections into the top view projections over here. These rectangular projections, they are not providing us with the actual shape of this semicircular vertical web. Next we observe that corresponding to this top surface of the horizontal web, that is element number 1, happens to be parallel to the horizontal plane. So this surface measuring 90 millimeter by 70 millimeter. So this will be projected as true shape projections into the top view projections over here. And another thing, because this circular hole, it is not visible to the observer from the top, so we are going to obtain the dotted line or hidden line projections corresponding to the circular hole into the top view projections over here. Next we have got this rectangular surface. So since once again this rectangular surface having dimensions width 18 millimeter, depth 70 millimeter, it is parallel to the horizontal plane. So into the top view projections we have been able to obtain true shape projections corresponding to this top surface of the rectangular block, which is again perpendicular to the front surface of the solid over here. Then we are going to encounter this circular cut section over here. So corresponding to this circular cut section, once again we are going to obtain apparent shape rectangular projections into the top view projections over here corresponding to this circular cross section of the top surface of the solid over here. And finally, corresponding to this surface of the solid, which is the top surface of the element number 1, because this rectangular surface, it is parallel to horizontal plane. So into the horizontal plane, that is onto the top view projections, we are able to obtain true shape projections corresponding to this surface of the solid. Further, we know that these two vertical edges, they are not visible to the observer from the top. So corresponding to the base of this T slot, we will be able to obtain dotted line projections over here corresponding to the bottom surface of this particular T slot, which is available over here. Again, we know that corresponding to the enlarged portion of this T slot. So the width from the center, it is equal to 20 millimeter on either side, so that the total distance from one extreme point and the another extreme point of this T slot becomes 40 millimeter. So from this center line, we have taken an offset of 20 millimeter onto the either side corresponding to this particular top portion of the T slot. So now two horizontal projector lines we have been able to obtain into the top view projections, which are separated by the distance is equal to 40 millimeter. So this distance is corresponding to these two vertical walls of the T slot, this vertical wall and this vertical wall. And these two horizontal projector lines, we have transferred them into the left hand side view projections using this transfer line over here. So now once again, this top vertical surface and this top vertical surface corresponding to this T slot, it will also not be visible to the observer, as the observer is going to look at the solid from the top. So once again, another couple of dotted lines or the hidden lines we are going to observe into the top view projections over here. Now let us proceed to evaluate left hand side view projections corresponding to this object. So as the observer is going to look at the solid from the left hand side orientation, now will be able to observe this radius of the semicircular portion as 35 millimeter corresponding to this vertical web or the element number 3. So we can check from this center point we have taken a radius of 35 millimeter and we have drawn a semicircular arc corresponding to this top surface of the vertical web over here. So now the radius we have taken as 35 millimeter over here. Another thing we know, corresponding to the base of the circular portion, we have been able to draw another horizontal projector line into the left hand side view projections view over here. So now as we are going to look at the solid from the left hand side, so this T slot, it will be visible to the observer into the element number 1. So into the element number 1, which is a horizontal wave, we have been able to obtain the projections corresponding to this T slot into the left hand side projection view over here. Now as we have already discussed that the height of the left hand side portion of the solid, it is 70 millimeter, while the height of the right hand side portion of the solid, that is element number 3, it happens to be equal to 85 millimeter. So now we can check corresponding to this portion, we will be having two vertical edges at a height of 70 millimeter from the ground, which will be visible to the observer corresponding to this surface and corresponding to this surface over here. And next we know that because we have got a flat surface over here, we can draw a flat horizontal projector line so that a rectangular projection we will be able to witness from the left hand side element number 2 surface over here, which is having total height of 70 millimeter from the ground. And now corresponding to element number 1, we know that this is the top surface of the element number 1. So this rectangular surface, it will be projected as an edge view into the front view projections at a height of 30 millimeter from the ground. Similarly, corresponding to this surface, which happens to be a vertical surface, which is parallel to the profile plane, we will be able to obtain the true shape rectangular projections into the front view projections over here. So these projections over here corresponding to the left hand side face of the element number 1. So these projections, they are also true shape projections over here, and these projections they are also true shape projections over here. Whereas corresponding to the circular cross section, we are not able to obtain the true shape projections into the left hand side view over here. So these rectangular projections which we have obtained corresponding to the circular portion of the element number 2, that is the rectangular block, so we are not able to get true shape projections over here. So these projections will be called apparent shape projections over here. So now we know that this surface, it is lying onto the rear side of element number 2. We know that into the left hand side view projections up to a height of 70 millimeter from the ground, the projections of the element number 3, they will be covered by projections of the element number 2 over here. So we can check corresponding to this circular arc portion, this portion we will not be able to see properly from the left hand side projections over here. So the hidden line projections will be available into the left hand side view projections over here. Similarly, we know that the height of the top surface of the circular hole, it happens to lie at a distance of 30 plus 20 plus 10, that is 60 millimeter from the ground, whereas the height of the surface is equal to 70 millimeter. So the circular hole will also be not visible from the left hand side orientation. So we can check through this center point, we can draw a circular projection into the left hand side view projections in such a way that this circular hole will be appearing as a dotted line or the hidden line projections into the left hand side view projections over here. Similarly, this portion and this portion corresponding to the semicircular top surface of this vertical web. It will also not be visible to the observer. So we can check this portion and this portion. It is not visible to the observer. That is up to the height of 70 millimeter. The circular portion of the arc, it will not be visible to the observer. Whereas the portion of the semicircular vertical web beyond 70 millimeter height, so this portion will be visible to the observer. So now we can join this portion of the vertical web corresponding to element number 3 using an object line or using a darker line projection over here. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections, and the left hand side view orthographic projections corresponding to this engineering object. So this is all for today. We are going to continue with further discussion regarding few more illustrative cases of the orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.